Hey everyone, so today I'm going to be teaching the string builder coding pattern, and this is probably the easiest coding pattern there is out there, but candidates still get this one wrong. So just, yeah, understand the string builder coding pattern because it's used in a ton of different algorithms. It's pretty much every time you're using strings, you should be thinking about the string builder coding pattern. So what exactly is a string builder? Well, string builder is an optimal way to build a string. It allows you to build a string in O of n time instead of accidentally causing it to be O of n squared time. And I'll show exactly what that means. So we're given this pretty easy question called defanging an IP address. We're basically given a valid IP address, return a defanged version of it. What we need to do in this question, it's pretty simple. Replace every dot with a dot with brackets around it. So you can see this address, all the dots got replaced with square brackets around the dots, right? And I'll show you the most naive approach first, and then I'll show you the optimal approach after using the string builder coding pattern. So let's talk about naive approach. So this would be the naive approach would look like. Say we have a result and we start with an empty string and then we'll return that. And we basically say for element in address, if the element is equal to a dot, so what we're gonna do is we have this result and we're gonna build up that string and return it at the end. And if the element is a dot, we're gonna append to our result the dot, but with square brackets around it. Otherwise, we'll just append that element, right? Hope you can see that why that works. So we add the one, so we have like this final, or we have this result right here. So if it's a one, we just add it there. If it's a dot, we kind of go like this, and we do the one, and we just keep appending, and then we have this string, right? So let me run this code. Let's see how long that it actually takes. So it takes about 40 milliseconds. Only beats 38%. So I'm going to tell you right now that this approach, it looks harmless, but it's actually causing, this algorithm is actually pretty inefficient. The time complexity is actually O of n squared. And the main reason that the time complexity for this is O of n squared is because strings are immutable. In Python, strings are immutable. And in a ton of different programming languages, strings are immutable. So what that means is we cannot update a string without creating a new one. So pretend I have like this long number, 1111111. Or let's do it like this, 1 2 3 4 5 6 7. And all I wanted to do was like add 8 to it. This won't behave like an array where we just add 8 to the end here, right? Instead, what it's going to do is it's going to have this string and this string, and it's going to create a new string. First, copy over all the elements in this string, 1 2 3 4 5 6 7. Had a power outage. But copy over that string. That's already going to take O of n time. That's going to take O of n time to copy over that string. Then finally add over 8. So we cannot, so it'll create the new string. So a simple operation like this won't just add the 8 to the old string. It'll create a new string, copy over all the contents of the first string here, then copy over this, like the other part of the string that we want to append. into this new string. So that leads to O of n operation instead of a simple O of 1 operation. So it's inefficient. So given that logic, this right here is actually leads to O of n time. So because our result is already a string, it's immutable. So every time we append to it, we have to copy what's already in result into a new string, and then append this dot with the squares or this element. So this actually leads to O of n operation. And then if we loop for every element in the address, this leads to O of n operation as well. So O of n, so for every element, we have to go O of n. That leads to O of n squared times complexity in general, which is very inefficient. So the string builder pattern, actually gets us to a time complexity of O of n. So how exactly does it do that? So it does that by, instead of using a string which is immutable, we use an array which is mutable and has O of 1 inserts. Amortize. I have a video on arrays of why sometimes when you insert to it, if the array is already at capacity, it'll create a bigger array, copy all those elements into that bigger array, but that bigger array will be double the size, and then append to it. But that's a story for, go watch my arrays from scratch, arrays theory, to understand that. But arrays, let's say arrays are mutable and has O of 1 inserts. So how do we do this question using the string builder pattern? Well, instead of using a string here, which is immutable, we'll switch to an array which is mutable, and then we just append to the array here. See, we append to array that O of 1. We append the element here. That's O of 1. So now this whole operation here is O of n operation. So we don't have a string, right? So the last thing we need to do is just do a join, which will create that string. So we do join on the result, and this join is another O of n operation. But as we know from time complexity theory or big O analysis, O of n plus n, I mean that gets to 2n, and you just drop the constants, it gets you to just n. So we do dot join on the result there. That should be an O of n operation. So now this whole thing is O of n, and let's run the code. Still 39 seconds, still super slow. I don't know if I can trust this lead code thing, but yeah, that's essentially what the string builder pattern is. You need to be able to use this. You'll see this a lot in different questions. The question might not tell you to do a string builder right away, but like within the question, you should be thinking about this, because you don't want your simple string operations to make your whole algorithm inefficient. So yeah, that's something good to know. One of the most basic coding patterns, but I hope you learned something, and I'll see you in the next video.